Yeah, what's going on? My fifth graders. How we doing today, ladies and gentlemen? Doing all right? Excellent. What I'm gonna do, I'm gonna take just a couple minutes of your time to review session 3 from yesterday. I know some of us probably didn't watch it just yet, and some of us probably didn't do the exit ticket from session 3. So I'm gonna take a couple of minutes just to review so we can spend most of our time on today's session, session 4. So again, if you have not done so, after this lesson today, I would love for you to go and check out session 3 and complete the exit ticket if you have not done so. All right, so for those of you who have already completed session 3, let's take a look at what we've learned. All right, so the example that we were looking at in session 3 looks something like this. We have 1,429 times 42. So we've already learned two ways that we could multiply or to find the product. We know that we can use an area model to help us find the product, and we also know that we could use multiplication with partial products and multiplying by base 10 to help us find the total product as well. But for session 3, we learned how to find product using the standard algorithm. And I'm going to go through really quickly just to show us how we do that again, okay? So we have the 2. We're going to start in the ones place. We have 2 times 9, which gives me 18. I'm going to drop my 8 in the ones column and then carry over my remainder or my 1 from the tens place over to the tens place. So now I have, again, we're staying with the 2 and the ones. We're now going to multiply the 2 times 2, which gives me 4 plus 1 is 5. Now I'm going to multiply 2 times 4 is 8. And then I'm going to multiply 2 times 1, which is 2. I'm going to drop a 0 underneath the 8 to hold my place value. Now I'm working with the tens place, the 4. We know that 4 times 9 is 36. So I'm going to place my 6 in the ones place of the 36 and then bring over the 3. Carrying over the 3. 4 times 2 is 8. Plus 3 is 11. I'm going to drop my 1. Carry my 1. 4 times 4 gives me 16. Plus my 1 that was carried over is 17. I'm going to drop my 7 and carry my 1. 4 times 1 gives me 4 plus 1, that's 5. So these are my partial products, right? They're pieces of the entire product that I'm going to add together, and that sum is going to tell me the whole product, okay? So 8 plus 0 is 8. 5 plus 6 is 11. I'm going to put my 1 and carry my 1. 8 plus 1 is 9. Plus my 1 that I carry is 10. Put my 0, carry my 1. 7 plus 2 is 9. Plus 1 is 10. I'm going to drop my 0, carry my 1. And last but not least, 5 plus 1 is 6. So my answer, 1,429 times 42, is 60,018. We rate that as 60,018. All right? So that is how we use the standard algorithm. All right, kiddos. So now that we've got the standard algorithm down, I want to revisit how to use the multiplication technique, the long multiplication technique with partial products of base 10. So I am going to put a little squiggle. I'm going to use the same problem, and let's see if we come up with the same answer or the same product. So for example 2, I'm going to take again 1,429 times 42. All right, we know that 9 times 2 gives me 18. And then 2 times, if I cover that 9 up and make it a 0, 2 times 20 gives me 40. So over here, I'm going to write how I'm doing this. 2 times 9, 2 times 20. Now I'm going to take 2 times, cover these two numbers, and put 2 zeros in place. 2 times 400. 2 times 400 gives me 800. I'm going to put my 8 and then my 0 and my 0. Make sure that you keep it lined up, okay? 2 times 400. And now I'm going to do the 2 times the 1, which is in the thousands place. So 2 times 1,000 gives me 2,000. If I add this up, what am I going to get? 8 plus 0 plus 0 plus 0 plus 0 is 8. 4 plus 1 is 5. 8 plus 0 is 8. And 2 plus 0 is 2. So I got 2,858. That is partial product number 1. Let's call that partial product number 1. Now let's find the partial product if we're using the 4 in the tens place. 4 times 9 gives me 36. So I'm going to do that under here. Yep, hope I have enough space, guys. And excuse my back again, I'm a lefty. 4 times 9 gives me 36, right? Actually, whoa. Here's a mistake. It's not 4 times 9, it's 40. So imagine this 2 becomes a 0, right? 40 times 9 is not 36. Now that is going to be 360. 360, okay? Now 40 times the 2 in the tens place, 40 times 20. 40 times 20, I know that they have 2 zeros, and 4 times 2 is 8. So that is 800. Now 40 times 400. 40 times 400, that is 1, 2, 3 zeros. I'm going to drop my 3 zeros. And then 4 times 4 is 16. All right. And then now 4 times 1 in the thousands place. So 40 times 1,000, that's 1, 2, 3, 4 zeros. And then 4 times 1 is 4. I'm going to add all this up. I hope I got enough space, guys. 0 plus 0 plus 0 plus 0 is 0. 6 plus 0 plus 0 plus 0 is 6. 3 plus 8 is 11. It's important that I keep it lined up in the appropriate column so that I add up the right numbers. And then 6 plus 1 is 7. And then 4 plus 1 is 5. I want you to take a couple of seconds. If this is my partial product 2, what am I going to do with 57,160 and 2,856? I need a second. It is hot. It's blazing in here. Holy moly. Okay. If you said add the partial products, you are correct. And if I add these two partial products together, I should get that same product from example 1. So let's see what happens. I've got 5, 7, comma, 160 plus 2858. Let's check it out. 8 plus 0 is 8. Same 8. 5 plus 6 is 11. Carry my 1. 8 plus 1 is 9 plus 0 plus 1 is 10. Put my 0. Carry my 1. 7 plus 2 is 9 plus 1 is 10. Put my 0. Carry my 1. And 5 plus 1 is 6. So we got 60,018. Is this and this the same thing? If we got the same answer both times, then both methods are correct. And just taking it a step further, guys, do you see how this was our partial product 2? This is our partial product 1, partial product 2, partial product 1. Do you also see how we receive the same partial product up here when we use this standard algorithm? So the standard algorithm, instead of me telling you the similarities between the two, let's hear from my friend, Miss D.
In both models, you multiply by ones and then by tens. The models record the multiplication differently. The partial product model records each multiplication separately. In the standard algorithm, you regroup as you multiply and record the partial products for ones and tens in one row each.
Thank you so much for that comparison, Ms. D. I really appreciate it. Ladies and gentlemen, you know I couldn't let you go without a recap. No cap, let's recap this lesson really quickly to stamp what we've learned. All right, so looking at when we use the standard algorithm, right? We had the problem 1,429 times 42. What we did, be quiet, y'all. What we did, we set it up vertically. After we set up our problem vertically, whoa, that's going in the bloopers. After we set up our problem vertically, right, we started multiplying with the ones place, the 2 in the ones place right on the bottom. So we multiplied 2 times 9, 2 times 4, 2 times 2, 2 times 4, 2 times 1. That gave us a partial product of 2,858. Then we regrouped as we needed and carried over the ones as we had to, right? Then we multiplied with the 4 in the tens, 4 times 9, 4 times 2, 4 times 4, 4 times 1, and we regrouped as we needed. And that gave us 57,160. After we got our partial products, we added them and found the sum, which is the total product of 60,018. I hope that I was able to help you recap lesson 3. Knock out that exit ticket for session 3 if you have not done it already, and join me back for session 4. As always, take care, ladies and gentlemen. Peace.